The topic that we have today is actually a very interesting one because it is the reason for so many of different phenomena, and that is intermolecular forces of attraction. I'll call it IMFA. Now, intermolecular force of attraction is, as the name suggests, it is the forces between the different molecules that you have. And these forces come from the idea of bond polarity. So first, let's talk about what bond polarity is. And to do that, we need to understand a concept called electronegativity. In the simplest terms, electronegativity is the ability to attract electrons. And we usually say it's the ability to attract shared pair of electrons, because electrons are always shared in pairs. So it's always the ability to attract shared pairs of electrons. So whenever there's a covalent bond, something accepts electrons. In fact, even if there's not a covalent bond, that still means that something is attracting the electrons of maybe some other thing. So maybe something is attracting electrons of a neighboring molecules. And it all comes down to how strongly does it attract that? Kitni zyada attraction hai. And that attraction obviously depends on the size of the atom. A smaller atom will find it easier to pull on these valence electrons because the distance is less from the nucleus. Attraction will be stronger. Similarly, if two atoms are joined in a bond, let's take the example of chlorine, for example. So chlorine, when it bonds to another chlorine, they're sharing two electrons. Let me show them like this. Of course, there are other electrons of chlorine, but they are not being shared at the moment. So I can just show them on the sides. These are called lone pairs, as you already know. And this is called bond pair. Now, this bond pair is being pulled by this chlorine as well as this chlorine. But because this chlorine and this chlorine, both of them are the same size of atoms, they both pull with equal force. There's absolutely no difference in one chlorine and the other. They have same shielding because they both have an internal shell, two internal shells actually. This electron is in the third shell. So they have the same shielding, they have the same attraction. So the attraction and repulsion, they're all the same. So that means the sharing is symmetric. The electrons are symmetrically distributed. Okay, so that is when you have equal electronegativity. But when you don't have electronegativity that's equal, let's say I have HCl. In this case, there is a pair and there are other pairs as well, but let me just talk about bond pair. That bond pair is being pulled more by this chlorine and less by this hydrogen. Sure, chlorine is a much bigger atom, so there's going to be some shielding, and hydrogen is a much smaller atom, so there's no shielding, it's in the first shell. But the attraction from chlorine is far stronger than the repulsion from the shielding effect. So what happens is that these don't stay in the middle. These electrons are actually more towards the chlorine side. And this we say will cause this chlorine to be slightly negative and this hydrogen to be slightly positive. The slight thing is shown by this weird D. It's like a swan or an S. It's called a delta. So the delta means small, and there's a small negative and a small positive charge. And this we show that electrons are not equally shared. In fact, people have done experiments to figure out how the electrons are distributed. And it has been verified that electrons are asymmetrically distributed. Okay. And why is that? The simplest way of saying that would be like, we don't want to talk about shielding. We don't want to talk about the size of the atom or the radius or the attraction from the nucleus. If we want just one word to explain it, we say chlorine has a higher electronegativity than hydrogen. And that means it will pull on these electrons way more than hydrogen can. Now, in such a bond, you will get what we call dipoles. So these two are called dipoles, this one, okay? And dipoles are always positive and negative, of course. And this makes the bond polar. But that does not mean that the molecule is polar. हमने last time भी इसकी बात की थी कि just because the bond is polar does not mean the molecule is polar. When is a bond polar? Usually, just for the sake of simplicity, we say that anything that is being bonded to these four will have a polar bond, provided it has a large difference. So as long as the difference in electronegativity is beyond a certain threshold, we call it a polar bond. Okay. So we use the idea of polarity and the difference in electronegativity.
Sir.
Yeah.
So I have a question from like the last class.
Yeah. Go on. Ask.
There was this one molecule you drew. It was C double bond C. ऊपर H था और नीचे Cl था. इसके किस तरह like cancel out हो रहे थे? क्योंकि अगर Cl is more negative than H, shouldn't it be going like ऊपर? No, Cl was with the दूसरे वाला Cl नीचे.
यहाँ पे
Yeah.
हाँ, तो इसमें देखो ना, ये डायपोल मोमेंट नीचे को है, ये डायपोल मोमेंट भी नीचे को है, सो ये तो ऐड होंगे.
Oh, but like won't we consider H इसके अंदर यहाँ पे हम सिर्फ Cl को करेंगे?
देखो, we do consider H, but the impact of H is much less. The impact of chlorine is much higher. So we only consider the more significant one.
Okay, और फिर हम हमेशा like central वाले atom के साथ करते हैं, like C और Cl को.
Yeah.
Like not okay. Take.
Another way to figure this out is that how does the bond polarity between carbon and hydrogen go about? कुछ बहुत ज्यादा नहीं होती है, ऐसी है.
Yeah, ठीक है.
Yeah.
Thank you.
But the bond between carbon and chlorine वो ज्यादा polar है, तो हम उसको ज्यादा consider करेंगे.
Makes sense. Okay.
Yeah. Usually we say that if the bond, the difference in electronegativity is between 0 and 0.4, the bond is non-polar. If it is between 0.4 and 1.7, the bond is polar. And if the difference is greater than 1.7, the bond is ionic. Okay?
So are we supposed to like remember this?
Not necessarily, but just gives you a good idea of how roughly the bonds are like. Okay? And it's not very exact. You can always like find exceptions, like HCl में बहुत ज़्यादा इतना फर्क नहीं होता है. But if the dipoles all add up, or they are all just like vectors, if they're all in the same direction, we will get a polar molecule. But if they cancel out, we will get non-polar molecules. A very simple example of this is carbon dioxide. Carbon dioxide has polar bonds. There's a slight positive here, slight negative here, slight negative here. The dipole moment is towards this on this bond and towards this on this bond. But because it exactly cancels it out, the overall molecule is non-polar. All right.
Great.
Yeah. So that's how the bonds are. Now, here's the thing. What does this have to do with intermolecular forces? Thing is that these dipoles in here, they come from the internal structure of the atoms. We call them permanent dipoles, but there can be temporary dipoles. When one molecule comes close to another molecule, because molecules are nothing but clouds of electrons moving around, one cloud, when it comes close to another one, it can repel the electrons that are already there. Let's take carbon dioxide, a completely neutral molecule. Let's say it approaches another one. If it comes close to it, it is likely that it will repel the electrons that this one already has. And if it does, if one molecule repels the electrons on the other one, it will create what we call a temporary dipole. It is a very simple example जो हमने grade 10 में किया था, that if you have a sphere of a metal that you join with wood and you bring a negatively charged rod close to it, what happens is that the electrons that are already here, they get repelled to the opposite side, leaving positive charges here. This is called induction, right? Because there's no physical contact. It's just one is close to another one. Just like that, when one molecule which has electrons comes close to another one, it pushes its electrons away, it scares them away. And when it does that, there's going to be small dipoles being created. Let's take noble gases, for example. I have argon. I have another argon. When this one approaches this, the electrons from this side are repelled to this side. So there's a slight negative charge created on that side and a slight positive created on this side. This is all in the cloud. Or iska bhi cloud hai. When this positive charge is made, it obviously pulls more on the argon's electrons, creating a new slight positive, slight negative charge here, जिसकी वजह से यहाँ पे slight positive charge create हो जाएगा. Because the right one, this was induced dipole. But because of that induced dipole, this was a temporary dipole that was created. हाँ वो थोड़ा सा मूव करेगा kinetic energy की वजह से, तो वो दूर चल जाएंगे. And there's going to be a force of attraction between this slight negative and this slight positive. And this force is called van der Waals, also called London dispersion force. सिर्फ इतना हुआ है कि एक उसके पास आया है, वहां पे there is an induced dipole and the electrons are slightly shifted, and in that instant a dipole is created. That dipole pulls on the electron on the other side, giving a rise to another dipole. But because electrons are all in constant motion, कभी भी वो इतना symmetrically distributed नहीं होता, तो उसकी इंडक्शन होती रहती है और वो मूव करते रहते हैं, और उसकी वजह से these are constantly disappearing and reappearing. But here's the thing, at no point in time are they repelling each other. Overall, the forces are always attractive. क्योंकि अगर एक भी डाइपोल है तो उसकी वजह से दूसरा डाइपोल टेम्परेरी बन ही जाना है और उसकी वजह से अट्रैक्शन आ जानी है. एंड इफ यू हैव लिक्विड आर्गन फॉर एग्जांपल, तो उसमें ये स्ट्रॉन्ग इतनी स्ट्रॉन्ग नहीं होगी, बट द फोर्स ऑफ अट्रैक्शन विल बी देयर. व्हाट डज दिस डिपेंड ऑन? ऑफ कोर्स द स्ट्रेंथ ऑफ द डाइपोल. एंड वेयर वाज द डाइपोल कमिंग फ्रॉम? कौन सी चीज थी जिसने डाइपोल इन द फर्स्ट प्लेस क्रिएट किया था? बताएं मुझे. What was it that created the dipole in the first place? It was the electrons. It was the electrons. जो argon के electrons थे, उनकी वजह से dipole create होया था ना. So the strength of dipole increases with number of electrons. So let's try this out. Let's say I have helium with just 2 electrons. I have neon with 10 electrons. उसका डायपोल इससे ऊपर होगा स्ट्रेंथ में या उससे नीचे होगा? अगर ये हीलियम है, नियॉन का इससे डायपोल स्ट्रेंथ में थोड़ा सा ऊपर होगा, because it has 10 electrons in the dipole. आर्गन का उससे भी ऊपर होगा, it has around 18. क्रिप्टॉन का उससे भी ऊपर होगा, I don't remember exactly, I think it has like 35 or something. और xenon का इससे भी ऊपर होगा. So the dipole is going to be strengthened by having more and more electrons. So no wonder the strength of dipole increases, and so the strength of van der Waals forces increases. So the boiling point increases. Density increases because the molecules are being pulled more together. Sorry, these are not molecules, these are atoms. But now, let's take halogens. How many electrons in fluorine? They exist as F2. So fluorine has 9 plus 9, 18 electrons. उसके इलेक्ट्रॉन आर्गन के इलेक्ट्रॉन के बराबर हैं, तो डाइपोल बराबर होना चाहिए. It depends on the size of the cloud. But roughly, because the electrons are roughly the same, the boiling points of fluorine and argon should also be roughly the same. And that is actually true. Fluorine and argon have roughly the same boiling point. Very close together. Because the number of electrons in the cloud is much close together. But then we have chlorine, and we have bromine, and we have iodine. The dipoles between these are actually much, much stronger than the dipoles between noble gases because their MR are also increasing. So not only do they have more electrons, they also have a much higher MRs, which is why इनके जो dipoles होते हैं बहुत ज्यादा हैं. But वही ट्रेंड जो नोबल गैसेस में हमने देखा, वही ट्रेंड यहां पर भी फॉलो होगा. Their boiling points will all increase, their densities will all increase because the strength of induced dipoles are increasing. So, for example, will we see the same thing in between, let's say I have these things. These are all in group 14 or group 4. They're hydrides. They are compounds of group 14 elements with hydrogen. Which one will have the biggest or the strongest dipole force or Van der Waals force or London dispersion force? Go on, tell me. Which one?
So the strongest.
Yeah.
CH4.
Let's see. CH4 has the lowest MR and the lowest number of electrons in the cloud. So the two important factors are MR and number of electrons in the cloud. If they go higher, the overall dipole forces go higher, the strength goes higher. So obviously they are increasing this way, the number of strengths will also increase this way. Okay. And so this has lead hydride has the highest boiling point. Methane has the lowest boiling point in all four of these. That's how it works. Larger molecules, more electrons, stronger dipoles, stronger intermolecular force. And of course, that affects the density, that affects the boiling point and everything. And that's okay. But इनमें एक problem है. अगर मैं group 6 में देखूं ना, so I have H2S, I have H2SE, I have H2TE, I have H2O. If I talk about these, MR and number of electrons. So this one has the highest MR. This one has the highest number of electrons. But when it comes to the boiling point, this one is the highest. और थोड़ा बहुत फर्क नहीं है. This one is a liquid at room temperature. And iska boiling, sorry, it's a gas at room temperature. Iska boiling point is slightly below 0. But iska boiling point is way beyond room temperature. It's 100 degrees Celsius. Let's see, ये trend बाकियों में भी आता है. Like this one has a highest boiling point in all of these. Okay, let's try it for group 5. So group 5 has NH3, PH3, and the rest of them, जो भी उनके बनेंगे. Turns out NH3 has the highest boiling point in all of them. Let's try in group 7. In group 7 or 17, you have HF, HCl, HBr, HI. Turns out HF has the highest boiling point. Highest boiling points. No, there is something very interesting going on here. Let's look at this. H2O, NH3, and HF. Have you seen them before? The three most electronegative elements making the highest boiling points of hydrides in their groups. This is some weird stuff going on. This is certainly not dependent on MR. This is not dependent on number of electron. It is something special. And this something special has a name. We call it hydrogen bond. This is a special kind of force, a specially strong force. That is when hydrogen is bonded to a very electronegative element. Nitrogen, oxygen, fluorine. HCl is not counted in here. This hydrogen bond has two things. First of all, in H2O, for example, or in HF, or in NH3, the two key ideas, lone pairs and hydrogen in a polar bond. These are the two major reasons why this is an important case here. Here's what happens. Let's say I have one HF. I react it, I bring it close to another HF. First of all, hydrogen is in a polar bond. And this lone pair can attract that. And that attraction is hydrogen bond. It is so strong, हमने इसको bond का नाम दे दिया. हमने इसे force कहा ही नहीं. In the case of ammonia, if I have another ammonia, then obviously the nitrogen and the hydrogen, they're all in a polar bond because the electrons are being shared asymmetrically. But this lone pair can attract this hydrogen, and this is an H bond, a hydrogen bond. But in the case of water, the situation is actually way on a different level. Not only is water able to make these bonds with itself, like there's the obviously the slightly negative and the slightly positive charges all around, but there's another thing happening. This lone pair can be attracted to this, and at the same time, this lone pair can be attracted to this. अमोनिया ज्यादा से ज्यादा क्या कर सकता है? एक मॉलिक्यूल दूसरे को, वो आगे किसी और को, बिकॉज एक एक लोन पेयर है उनके पास. और HF क्या कर सकता है? HF बहुत ही छोटे मॉलिक्यूल्स हैं. द साइज ऑफ फ्लोरीन एंड हाइड्रोजन मच स्मॉल. उनका बॉन्ड एंगल भी बहुत सिंपल सा है. तो उसकी वजह से क्या होता है कि वो एक तरफ से अट्रैक्ट करते हैं, दूसरी तरफ से बहुत स्ट्रांगली किसी को अट्रैक्ट नहीं कर पाता. तो एक मॉलिक्यूल के साथ जुड़ जाता है. But in the case of water, you have a much broader angle, 104.5. ठीक है? Ammonia में 107 है. But at the same time, ammonia does not have two lone pairs. Water does have two lone pairs. तो अब क्या होगा? Water is able to pull on two more water molecules through its oxygens, lone pairs, क्योंकि दो lone pair हैं तो दो water molecules को pull कर सकता है. And the two hydrogens that it has, they are able to make hydrogen bond with two other water molecules. तो चार molecule एक दूसरे के साथ जुड़े होते हैं. Which means that this combination of high electronegative distance, यानी कि high polarity, small size of hydrogen, makes it a really strong intermolecular force. And so water is able to have a way higher boiling point than any of the other hydrides in its group. And same for the others. And not just that, water is able to make this bond with other polar hydrogens. So when I put ethanol in water, water is able to make hydrogen bond with ethanol. क्योंकि ethanol में भी OH है और वो polar bond है और lone pairs हैं और water में भी है. Water is able to make that with acids, ethanoic acid for example. And the acids are able to make it with themselves or with other acids. So there is hydrogen bond everywhere. You have hydrogen in a polar bond and the other atom has lone pairs. In other words, fluorine, nitrogen, oxygen के साथ hydrogen होगी, polar bond है, hydrogen bond होगी. Yes. Hydrogen bond doesn't exist with chlorine.
I wanted to ask कि Cl में इसलिए नहीं होता कि किसके पास कोई lone pairs नहीं है.
Cl के पास lone pairs हैं, but the difference in electronegativity is not that huge. Also, the size of chlorine is much bigger. तो उसकी वजह से बॉन्ड जो है वो इतनी ज्यादा स्ट्रांग नहीं होती. What are the implications of this? तो एक हमने देख लिया कि परमानेंट डाइपोल्स थे HCl में फॉर एग्जांपल या COCl में, वो परमानेंट डाइपोल्स की वजह से वो एक दूसरे को ट्रैक कर रहे थे और इंटरमोलिकुलर फोर्सेस बड़ी स्ट्रांग थी, परमानेंट डाइपोल्स. Then we saw temporary dipoles, noble gases. We saw them in other non-polar substances. And then we saw hydrogen bond, which is a very special case. And that shows us that water is able to make that. And if water is able to make that with other molecules, those will be soluble in water. Like ethanol is soluble in water because ethanol can make hydrogen bond with water. लेकिन octanol is insoluble in water. क्यों? Because octanol में ठीक है, OH की वजह से कुछ हाइड्रोजन बॉन्ड तो होगा, but at the same time there's a huge non-polar tail. So octanol is going to have C8H17OH. So it's going to be a huge molecule that has a long tail of this side being non-polar and this side being polar. So this polar tail will be attracted with water, but the non-polar side will not be. तो उसकी वजह से क्या होता है, जितनी हाइड्रोजन बॉन्ड बनती है वो इस नॉन पोलर की वजह से इसको काउंटर नहीं कर पाती. Okay, sure, there is some hydrogen bonding that happens, but this does not do hydrogen bond. ठीक है, सो उसकी वजह से ये सॉल्युबल नहीं होता, बट एथेनॉल होता है क्योंकि उसकी टेल बहुत छोटी है. एंड दिस इज व्हाट वी डू. वी से दैट फॉर एग्जांपल सोप has a very long tail that's non-polar and on one side it is polar. So soap क्या करता है कि on one side it will bond with things that are soluble in water because it will have a polar side and that polar side will form hydrogen bond. But on the other side, this is non-polar and non-polar things have temporary dipoles. Over temporary dipoles, दूसरे temporary dipoles के साथ attraction करते हैं. And so soap is able to bridge the non-polar and the polar और उन दोनों को वो लेकर soap उतार लेता है, मैल वगैरह उतार लेता है, dissolve कर लेता है. What are some implications of hydrogen bonding? So first one is that in water, because water molecule, like in liquid water molecules are moving all the time, तो उनकी चार की एक के साथ bonding ideal case है. It doesn't really exist as much practically because they are always moving and the bonds are being made and broken all the time. But in ice, the movement is really rigid. वो बहुत ज़्यादा close together होते हैं जिसकी वजह से they get to form a lattice. Every water molecule is able to make that hydrogen bond with 4 other water molecules. तो उसकी वजह से क्या होता है कि एक टेट्राहेड्रल डायमंड की तरह का स्ट्रक्चर बन जाता है. And now, what is the bond angle in tetrahedral structures? 109.5. What's the bond angle in water? Like just the water molecule? 104.5. So because of the tetrahedral structure, the ice has a bigger angle. और bigger angle होने की वजह से the volume is lower. Sorry, volume is higher. So the density is lower. So ice floats. So ice is larger in volume than the liquid. So it floats. It is less dense. But when you melt it, the whole lattice breaks down. So every molecule comes closer to the other one, then they move away. So all of this keeps on happening as they get more energy and they're moving more rapidly. The bonds are broken more. So वो lattice उस तरह से बन नहीं पाती है. So उसकी वजह से water की maximum density 4 degree Celsius पे होती है और ice float करती है. In fact, this is the reason life exists. In DNA, we have hydrogen bond. We have 4 different bases. We have adenine that bonds with thymine through hydrogen bond. We have cytosine which bonds with guanine through hydrogen bond. It's remarkable how they do that. A will always bond with T and G will always bond with C. तो हाई तो होता क्या है, डीएनए के एक साइड पे ए जी चलता रहता है और दूसरी साइड पे थायमीन साइटोसिन थायमीन साइटोसिन थायमीन साइटोसिन चलता रहता है. And then they bond with each other and forms a ladder like structure. मतलब ये सारा ऐसे करके होता है और ये सारा ऐसे करके होता है. My drawing is not that good, but you get the idea. It forms a double helix structure. Okay, and that is hydrogen bond. We have to thank hydrogen bond for it.